proofs are not terrible with geometry, but what makes them hard is not knowing your theorems, your postulates, your definitions, your properties. So once again, I would remind you, and we've had to use it today a little bit in other classes, in the back of your textbook, in that little sea green section. Have I said this before in here already? Okay, let me tell you. So back here, I'm going to model with Caleb's book here. Thanks for letting me just grab it off your desk without asking. That was rude. I apologize. All right, so back here, where it's like a sea green, aqua, blue, teal, whatever color you want to call it. This section, the book does a wonderful job of organizing just chapter 1, postulates and theorems, just chapter 2, postulates and theorems. There are some things in chapter 2 we haven't learned that we're going to learn today. So if you're using this today during the lesson and you have your book open to this, you want to be careful, because if we haven't mentioned it, and it sounds like you've never heard it before, you probably haven't, because there's still several theorems we're going to learn in the next couple sections, okay? But when you're doing your proofs at home and you're like, I don't have any idea where to go from here, open it up. Read through your postulates and theorems you've learned so far. And again, not to scare you, but I do want to warn you, as our definitions go down and we have less and less words on our vocab tests, look what happens to our postulates and theorems. We learn more and more and more and more. So they increase. We learn more postulates and theorems, but less definitions, okay? So this is a great place, though, for you to go back and say, okay, I just need to study and review. The one thing I promise you, okay, this is a promise, when we get further in the semester and we're in chapter 6 or chapter 8 and we're trying to write a proof, there's a lot of theorems by then we will have learned, right? When you have a proof on your test, it will not have some theorem back from chapter 2 that we have not recently reviewed. So if it's going to be on your test, then we will have mentioned that theorem in one of two places. We will have either talked about it in the notes, and it would have been in one of our examples, or you would have had to use it on your homework. And you'll have your homework back graded, so you'll know if you didn't know it when you did the homework, you'll at least know it was there when I graded it and wrote it in for you. I will not put something on the test that we have not that chapter recently reviewed. Okay? So it's not like when we get to chapter 8, you're writing a proof and you've got to make sure that you know every single one of those theorems that we talked about way back today. Okay? Is that fair? All right. So I promise you I'll do that for you. Okay, so when you're writing proofs, we started these last class period the way that we're going to do them today, which is going to make it so much easier. We did them in 2-column form, so we're going to do 2-column form today. Every proof you're going to do is 2 columns, statements on the left, reasons on the right, numbering every statement and reason. What's going to happen today is they're going to give you some hypothesis. That is your given. They're going to give you information. Then they're going to tell you to prove some conclusion. That's going to be your goal. So they're going to give you a hypothesis. They're going to tell you to prove this conclusion. Your job is to figure out what are the steps and the reasons that take you from the given to the conclusion. And the only things you're going to use in that reasons column are definitions, postulates, properties, or theorems. So today, whenever we're working these examples, don't start trying to explain to me, name the theorem, name the postulate, name the definition, name the property. Okay? So if I say, why do we know this? You're going to say, definition of midpoint, vertical angle theorem, segment addition postulate. You're going to pick a postulate or theorem or property that is the reason. Does that make sense? Okay. So we're going to start off pretty easy. They're going to give us some fill-in-the-blank proofs where you're just having to come up with maybe just the reasons. And then we'll look at some where you have to do some statements and some reasons. And then we'll eventually get to ones where we're doing the whole thing all by ourselves. So we'll start off with kind of a baby proof. On this first slide, I forgot to put the 4 statements, and so now if I slide them, it's going to give you the reason, and I don't want to give you the reason. So can you guys help me out? Go ahead and make a statement and reasons chart above it so that you have your 4 statements here. Put statements on the left, reasons on the right. And then can somebody read to me what the first statement says? Is it the given? that's up here? Does it say? Ang- I think you're on the one below. Look at the one to the right that's like this. Okay. Angle A and angle B are supplementary. Does it give you anything else in number one? Okay. And measure of angle A is equal to 45 degrees. Okay? And then is statement 2, measure of angle A plus measure of angle B is equal to 180. And then 3 is 45 plus measure angle B equals 180. And then we have measure of angle B equals 135. Right? Okay, so this will be what your homework looks like where you have to fill in the blank. Right now I'm going to say this and I'm going to write it in great big letters on the board. You must write the whole proof. You are not allowed to fill in the blank. Do not just write the missing parts. Every single proof, whether you're doing it by yourself or you're filling in the blanks, you are going to write the whole proof down. And I'm making you do that so that you're thinking through every single thing that you're writing, not just the missing pieces. And that way also when you get your proof back, your homework back, you've got the whole thing there so that you're not just going, oh, I missed part A, I have no idea what that was. You can read that whole proof and see, oh, now I see why it should have been that. Okay? So you're going to write the whole proof down, not just fill in the blanks. All right, so all we have to do is figure out what goes here. The given should be the easy part. You read through the part at the top. Which number here is the given? Number 1. Given that angle A and B are supplementary and A is 45 degrees. Given, okay, I'm going to warn you again. On some of these fill in the blank problems, they do not always put all the given in number 1. Sometimes they'll put part of the given in 1, part of the given in number 5, part of the given in number 7. So when you first start your proof, the very first thing you should do is look to see what's all the given. A and B are supplementary. A is 45. Is all of that in number 1? If it is, you're done. If not, go find the rest of your given and put given for the reason. Because it never fails. I'll have students who will call or text me or come in and say, I have no idea where statement 6 came from. And it's because it came from the given and they didn't check that first. And so there is no way to know it except that it had to be given to you. Okay? All right, so now you're looking for reasons, definitions, theorems, postulates, or properties. What tells us if they're supplementary that now we can say A and B add to be 180? Careful, angle addition postulate says if you have a picture of an angle that's being split into 2 parts, then part plus part equals whole. But our picture does not have 2 angles put together where a part plus a part equals the whole. So it's not angle addition. It's coming from this statement here. So what tells me that if they're supplementary, that they add to be 180? What definition, theorem, postulate, or property tells me that if 2 angles are supplementary, that means they add to be 180? Exactly, definition of supplementary. They said they were supplementary. What does supplementary mean? Adds to equal 180. So this is just the definition of supplementary. Okay? Now you're going to look at what you have, and I should have said this to start with. When you're working through your proofs, you're going to look 2 places. You're either going to look at what do I have right up above, which is what we just did. You're looking at what we had right up above and saying, okay, how do I know this from up above? If there's not anything from up above that tells us that, it could be a picture, and then we go to the picture and say, okay, is there something in the picture that I'm using? In last class period, we used the picture, right? We said, oh, we have segment addition postulate or we have angle addition postulate. So this time we were able to use what we had just up above. Okay, so same idea for number 3. You're going to look at what you have up above and ask yourself, so now there's 2 things you have up above. How did they get from 1 and 2 to 3? Perfect. Don't mark in your proofs, but I'm going to mark up here just to show you. They said A was 45, so they just substituted in that 45 for angle A. So that is substitution property of equality. Good. All right, and then when we look at how we got 4, so now ask yourself, how did they get from 1, 2, and 3 to 4? What did they do? Good. So if we look at what we had in 3 and now what we have in 4, all they did was subtract 45 from both sides of the equation. So that is subtraction property of equality. So every time you're looking at what do I have up above, how did I get from there to here? Keep doing that every time. And if you get stuck and say, I don't know how they got there, then go look at the picture. Could be from the picture. Okay? Any questions so far? All right, look at the next one. Go ahead and make a statements and reasons chart. Number your reasons 1, 2, 3, 4. And I'm going to give you about 2 minutes, and I want you to see how much of that you can fill in on your own or with your partner. Very good. Okay, let's check and see how you're doing. So, first of all, I saw most everybody did what they should have done. They should have looked for what first? Given. And which numbers were the given? 1 and 3. So 1 should be given, 3 should be given. That's going to keep you from getting to question 3 going, where did that come from? Okay? So then be careful, though, that you don't skip over some of those things they've given you just thinking, oh, it's already filled in my proof. You need to reason through what you're doing. So B is the midpoint of AC, and then the next thing they said was AB then is congruent to BC. What tells us that if B is the midpoint, then AB is congruent to BC? Definition of midpoint. What does it mean? What does the definition of midpoint say? It is a point that splits a line segment into two congruent parts. And that's exactly what they said. If B is the midpoint, then the two parts are congruent. If then, given that it's the midpoint, then we can conclude this. So definition of midpoint. Don't make that harder than it is. Look at the key word. They gave you midpoint. Use that word and its definition, okay? This is where you don't want to just jump down to number 4. Look at what you have in 2 and 3 and ask yourself, okay, how did they take 2 and 3 and get number 4? 2 says AB is congruent to BC. 3 says AB is also congruent to EF. 4 says BC then is congruent to EF. What did they use? Very good. Transitive. Notice that this left side is the same on both of them. If one whole side is the same, we get rid of it, and we can then combine the next two parts. So we have transitive property of congruence. Is this making sense? Okay, hardest part's going to be knowing what you can use, knowing those theorems, knowing those postulates, knowing those properties, and knowing those definitions. They finally put the definition for theorem in your notes, but we learned theorem back in chapter 1 because I had you write down one of the theorems that we would need that they didn't introduce until later, and that was the vertical angle theorem. Do you guys remember? What did we say was true about vertical angles? They do share a vertex, but what did the vertical angle theorem say about those vertical angles? That they're congruent. So that was our very first theorem that we learned was the vertical angle theorem, okay? Even though they hadn't actually taught us the definition for theorem. Theorem is any statement that you can prove. What is a postulate? Okay. We accept it as true without proof. So postulates are kind of like common sense things. We just kind of believe them to be true. Part plus part should equal the whole. That's kind of more common sense. Theorems are things that we can prove true. So vertical angle theorem was one. Vertical angles are congruent. Hey. Do you want to give her a hug and tell her how much you love her? No, that's okay. Thank you. All right. So here is our second theorem that we're going to learn, which is the linear pair theorem. And we've actually talked about this already. We just didn't give it a name and give it a theorem. So think about a linear pair from chapter 1. Linear pairs are two angles that form a straight line, right? So what do we know a straight line is? 180 degrees. So the linear pair theorem says if two angles form a linear pair, that's your hypothesis. I love these charts and the way they're set up because what they do is basically show you how this would look in a proof. Your hypothesis could be one of your statements. So somewhere in your proof, you have angle A and B are a linear pair. If that's in your proof, then the next thing you could say is, so your next statement could be, that means A and B are supplementary. And the reason that you would put for statement 2, so reason number 2 would be the linear pair theorem. So if your proof says angles A and B are a linear pair, your next statement is they are supplementary. Your reason is linear pair theorem. Does that make sense? Okay. The second one here, our third theorem we're going to learn, second one today, is the congruent supplements theorem. This one's a little bit wordy, so I'm going to draw a picture to see if it makes more sense. It says if two angles are supplementary to the same angle. So I'm going to draw a picture here of two angles, 1 and 2. Would you agree those are supplementary? Okay, then I'm going to draw another two angles, but this time it's supplementary to the same angle 2. So angle 3. Would you agree that 2 and 3 are supplementary? Okay, so if two angles, referring to angles 1 and 3, are supplementary to the same angle, which is the same angle here? 2. So if 1 and 3 are both supplementary to 2, then that means 1 and 3 have to be what? Congruent. So in your proof, you might have statement 1 says 1 and 2 are supplementary. And then statement 2 says 2 and 3 are supplementary. If two angles are supplementary to the same angle, then those two angles are going to be congruent. That's the congruent supplements theorem. And I'm going to tell you we don't use it a lot until we need to use it again. And then you're going to forget it. And in fact, today in my double blocked class, we're in sections 4.5 and 4.6. And today we needed to use congruent supplements theorem again. And they didn't remember it from chapter 2. And we had to pull our books out. We had to look it back up again because they didn't remember this theorem. It's not used a lot, but you want to be able to use it because it saves a lot of time in a proof. Okay? So if 1 and 2 are supplementary, 2 and 3 are supplementary, 1 and 3 are congruent, congruent supplements theorem. Here's the only other thing that it says as well, but is not in my picture. It also says, or to two congruent angles. So here's how that could look. Let's say that angle 1 and angle 2 are supplementary. And then let's say that angle 3 and angle 4 are supplementary. So we don't have any of the same angles there, right? But what if they also told you angle 2 is congruent to angle 3? So now angles 1 and 4 are supplementary to two angles that are also what? Congruent. So again, look up here and make sure this is making sense. 1 and 2 are supplementary, 3 and 4 are supplementary, but angles 2 and 3 are also given to be congruent. So it's like they're the same angle, it's just they have different names, but they have the same measure. So that means 1 and 4, if they're supplementary to congruent angles, have to be what? Congruent. So then you could say angle 1 is congruent to angle 4. Does that really make sense? Yeah. So sometimes it may be that they're supplementary to the same angle, and sometimes it may be that they're supplementary to congruent angles. But either way, you can say that those two angles are now congruent. Congruent supplements theorem. Okay, I'm going to have us fast forward in our notes a little bit to the one that's called the congruent complements theorem, because it is the same thing, except it is now talking about complementary. So find this chart. Is everybody with me? Second one right here, congruent complements. Okay, it says the exact same thing, except instead of them adding to equal 180, we're saying if they add to equal 90. So again, a picture. If I have two angles that form a right angle, and then I have another two angles that are also forming a right angle, but one of them is the same angle. So again, if 1 and 2 are complementary, and 2 and 3 are complementary. I'm going to slow down because I can tell you're drawing that picture. Make sure everybody's with me. So do we agree that 1 and 2 are forming a right angle and are complementary? And 2 and 3 are forming a right angle and are complementary? So we have two angles that are complementary to the same angle 2. So that means what about angles 1 and 3? They are congruent. Because they are complementary to the same angle, they have to be congruent. Same thing, except we're dealing with complementary, meaning 90, versus supplementary, meaning 180. Okay? And again, I'll point out, it could be that they are complementary to two congruent angles. So once again, it could be that angles 1 and angle 2 are complementary, and angles 3 and angles 4 are complementary. But then they also tell us that angle 2 is congruent to angle 3. just like before. So if you have two angles complementary, a different two angles complementary, but one of each of those pairs turns out to be congruent, and that means that 1 and 4 are going to have to be congruent. And that's the congruent complements theorem. Does that really make sense? Okay. And then the last theorem that you'll see here today is the right angle congruence theorem. This theorem saves a lot of time in proofs too. Right angle congruence theorem, it simply says all right angles are congruent. So the way that'll look in a proof, you have that angles A and B are right angles. Instead of saying I now know that that means they equal 90 degrees, and then using transitive to say that they're equal to each other, and then using the definition of congruent to say if they're equal, that means they're congruent, we can just do the very next step and say if they're right angles, they're congruent. And the reason for that statement would be the right angle congruence theorem. Does that make sense? If you don't use that theorem, you're going to have 3 steps you're going to have to do instead of just 1. You're going to have to say they equal 90. You're going to have to use transitive to say they're equal to each other, and then definition of congruence to get their congruent. And we don't want to do that. We want to make it quick and easy, right? Okay. I think that's all I wanted to do. Yeah. So let's go back to the beginning, things that I skipped. I hit the button too many times. So what's the next example that I skipped when I fast forwarded? Is it this one? Okay. So when we get back from lunch, we're going to check this in the next 2 minutes, though. Go ahead and see if you can have any idea what goes in any of those missing blanks. And then we'll talk through it when we get back from lunch. Remember that when we make our corrections in the core math book that I'm going to send Faith a picture of the corrections before we go. Okay? All right. Okay. So where we left off right before lunch was trying to figure out what goes into these blanks, right? Did anybody figure anything out? I barely gave you about a minute, but the first one is what, Malin? Sorry, 1 second. Mrs. Lashley? Yes, ma'am. She actually just got her assignment and is headed your way and said you guys were leaving now. Yes, so she's on her way. You're welcome. Bye. Okay, so what was it again, Malin? Number 1? Good. And so just a little bit of advice, if you didn't have that written down yet, the first thing we're looking for is given, right? Because we want to make sure we've got that filled in. But the other thing you want to be careful about is it may not all go in number 1. So you want to make sure that you're looking in your proof and asking yourself, do I see the word given anywhere else? And we don't, right? And there is one blank that could be given, number 5, but when we look over at the statement, is that statement one of our given? No. So when you get to those fill in the blank proofs, make sure you check and see. Don't put it all in number 1 unless it all goes there. See if it's anywhere else. But you did great. I'm going to be a little bit lazy here and just circle all this and point to right here if that's okay. All right, speed things up there. Again, when you get to the homework, you are writing the whole proof, not just 1A, here's my answer. Write it all out, statements, reasons, list it all, because I want you to think through what they did to help you when you get to where you're doing it all by yourself. So let's make sure we understand. They said they were supplementary. Notice what they did next. They used the definition of supplementary to say what?
Measure of angle 1 plus measure of angle 2 equals 180.
Okay, so they said that the definition says they add to equal 180. So then they took both of those statements and wrote equations, right? Then there's a typo. This is not technically substitution, and I hate abbreviations, so don't abbreviate. Even when you're writing it out, if they abbreviated, you do not abbreviate. But this is not substitution. This is transitive. Transitive property of equality. So now we have to figure out what would our statement be using that property. So look at what you have in number 2. How can we use transitive to come up with a statement for number 3? You're doing more than just transitive by doing that statement. Remember, transitive says if you have A equals B and B equals C, one whole side of this equation is identical to one whole side of this equation. Those go away. The entire side of this equation A equals the entire side of this equation C. So what's the part that our equations in number 2 have in common? Okay, I heard two different answers there. Measure of angle 2 and 180. They do both have a measure of angle 2 and they both have a 180, but you have to make sure you understand the concept of transitive here. It is not do they have a piece the same. It is one whole side of the equation identical to one whole side of the equation. So what is the side of the equation that is identical? 180, okay? So even though they have a little piece that's the same over here, it's not the whole side. So what we're saying, and again, you don't want to mark in your proofs, but for our notes, I'm going to show it. The 180 is what they have in common. That goes away. And now we're going to say A, which is all of the left side, equals C, which is all of that left side. So what's going to go here is going to be, and I'm going to write it over here where I have more room, okay? This is 3B. Measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. So we're saying this whole left side A equals this whole right side C, or in this case, it's the left and the left. Does that make sense? Okay. Number 4, I would tell you that I will not expect you to do when you write a proof for me. The only time you would have to know how to do this is if it's a fill in the blank and they make you fill in one of those two spots. Otherwise, as far as I'm concerned, you could get rid of this entire statement. And reason. They're saying 2 equals 2 by reflexive. We know reflexive says something equals itself. The only reason they're going to do that is because they want to make sure you understand that the measure of angle 2 on the left is the same as the measure of angle 2 on the right. It's not really necessary. We called it angle 2. It's going to have the same measure because it's the same name. So you don't have to have this number 4. Okay? So if you're trying to study for your test and think, okay, how would I write my proof? That step's not necessary. Okay, so now we're going to ask ourselves, how do we get from 3B here to number 5? What do they do from 3B to number 5? They took out the 2's, so they minused them. They said minus 2 minus 2. What do we call that property? Subtraction property. So again, instead of trying to cram this where that question mark is, I'm going to write 5C right here. Subtraction property of equality. Somebody thought they were going to call me, and then they said no. Subtraction property of equality. Again, you're not doing what I'm modeling here. You're writing the whole proof on your homework, right? Okay, the last statement should never be a question you have to ask yourself what goes there. It is always going to be what they tell you to prove. Okay, your last statement is always what they tell you to prove. It's another easy freebie point on a proof. The given should be easy, and what they're telling you to prove should be easy. So this, you are not done with your proof until exactly what they tell you to prove is your very last statement. So we know that number 6 has to be angle 1 is congruent to angle 3. But I want to make sure you understand how they got from 5 to 6 because we're going to use that all the time. What tells me that if two things are equal, that now means they are congruent? Exactly. So that is when we say it means, that's what a definition is. It's the meaning of something. So that is the definition of congruent. There is not a definition of equality that we've learned. So remember, definitions are biconditional. If they're congruent, you can say they are now equal. And if they're equal, you can say they are now congruent. And it goes both directions, and it's still just the definition of congruence. Does that make sense? You can say congruent angles. That's what that is. That's their little angle symbol. Or you can just say definition of congruent, and I'm okay with that. Any questions on this one? All right. I think on the notes we should have 2 left. 2 that I want to look at. Maybe we'll do both. Let me see. Oh, I skipped this little slide right here. Just a helpful hint as we progress through proofs. It's not so much for this chapter, but it will be later when we get to chapter 4. Chapter 4 is our most proof intensive chapter. It's the one where we write proofs for at least about half of the chapter, and it has the most proofs on the test. If there's not a diagram drawn for your proof, there's no picture, it is always going to be helpful to draw a picture. And a reminder that when you are starting a proof, you need to mark your picture with your given. Mark the given information. You're never allowed to mark the picture with what you're trying to prove. Do not mark what you're trying to prove. There's a question on your homework tonight, and it's going to ask you, what's wrong with these two? Which one of these two pictures is wrong? And why? One of them is going to mark the given, and it's going to be correct, and the other one's going to mark what they're trying to prove, and it's going to be wrong. You can only mark your picture with what you're given, not what your goal is to prove. Does that make sense? And by mark your picture, we're talking about putting the little tick marks, like if these things are congruent or these angles are congruent. What do I know? Mark my picture with those things. It's super important as we go on that you're drawing pictures and marking your pictures. Okay, so we'll do this one together, and then I'm going to let you try the last one on your own and see how we do. I want to warn you that the plan is not going to be given on a test. In the notes, I took it out, so you should not have this part that says plan, right? Okay. In the book, I can't take it out because you have your book already with you. So in the book, I'm going to warn you to try not to look at it. Okay? Try to ignore the plan because you're trying to do your homework like you're preparing for the test. And on the test, I'm not going to give you a plan. It's just simply going to say, given something, prove something. So you want to try to say, can I do it myself? But the homework's our practice. So if you get to the homework and you're like, I have no clue where to even start, then go ahead, read the plan and see if that gives you an idea of what to do. And then maybe on the next one, you're trying to do it without reading what the plan says. Okay, so practice, try not to use it if you can, then go back to it if you have to. All right, I'm going to go over to the whiteboard to write this because I'm running out of room. If you're watching the video, remember that this example is completely filled in on the notes part. So if you click on the notes link, you'll see this example all filled in perfectly for you. All right, you guys should have a statement and reasons box already. Let me draw mine. All right, so number one, what's the first thing we want to do? Write down the given. And I'm going to tell you, let's try writing down our given one at a time and see what we know from each given. So angle 1 and angle 2 are supplementary. Number 1, given. Okay, so before I write the rest of my given, what do you think we could say now if we know that 1 and 2 are supplementary? They add to equal 180. So we could write down the measure, don't forget your little m's, of angle 1 plus the measure of angle 2 equals 180. What tells us, what definition, theorem, postulate, or property, that we can do that? Exactly. Definition of supplementary angles, or just definition of supplementary is fine. Okay, so oftentimes I find it's easier if I write down one given and ask myself, what do I know now? And then I'll write down my next given and say, now what do I know? And that way I can kind of keep going through that thought process.
Is it okay if we ever just put like the angle?
Yes, you can always use your angle symbol. Okay, go on to our next given. Angle 1 is congruent to angle 3. Given. At this point, we need to look at what are we trying to prove and what would we need to get there. So what's our goal for this problem?
Prove that angle 3 and angle 2 are supplementary.
Okay, we want to prove 3 and 2 are supplementary. What does it mean if they're supplementary?
Equal 180.
They're going to add to equal 180. So our goal is probably to get measure of angle 3 plus measure of angle 2 equals 180, right? And right now we have 1 plus 2 is 180. And we know 1's the same as 3. And our goal is to get 3 plus 2 is 180. right? So that we can then say they're supplementary. So what do you think we might need to do? Okay, transitive, first of all, is either of equality or of congruence. So I would say that we have one is in equation form, one is in congruence form, so that would be a little bit of a problem, and we'll have to deal with that. But transitive also says you have to have the exact same thing on one whole side of the equation. This says 180, and I don't have that here. This has an angle 1, but it also has plus angle 2, and I don't have that here. Does that make sense? Okay, so it's not transitive. So what might I use to get my goal? Any ideas? It's okay. Good ideas. Sydney? Okay, so if 1's congruent to 3, would you guys agree that if we put 3 in for 1, then this would say 3 plus 2 equals 180? Okay, but the only problem we have before we can do that is that this is a congruent statement, and we only have substitution property of equality. So what are we going to need to do to this before we can substitute it in? We need to make measure of angle 1 equal to measure of angle 3. We need to change this from congruence to equality. So the first thing, and we will do that a lot, okay? So the first thing we need to do is change this to measure angle 1 equals measure angle 3. What tells me again if something is congruent, then it is equal? That's what we just looked at, that last step of that last proof. Definition of congruence. So definition of congruence. And then what Sydney said is where we can go next. We can replace this angle 3 in for just this piece angle 1, and since we're only replacing a part of it, it's not transitive, it's substitution. So number 5, when we plug this 3 in, we'll have measure angle 3 plus measure angle 2 equals 180. Is this making sense to everyone? Okay. And then the reason again is what for number 5? Substitution property of equality. Are we finished? No, we're close. We have to say exactly what it tells us to prove. So even though they mean the same idea, we still have to redo one more step. So if 3 plus 2 equals 180, then that means that angle 3 and angle 2 are supplementary. And then again, what tells us that? Definition of supplementary. And again, it's biconditional. Every definition is biconditional. So notice we started the process with these two angles are supplementary. So now we can say they add to be 180 by definition. And then we ended it with these two angles add to be 180. Now we can say they're supplementary by definition. So it is biconditional. Definition of supplementary. Questions? Okay, take a few minutes and you guys try the last one with your partner and see if you can get it, and then we'll check it. So again, if you were watching the video and didn't follow that, here it is filled in. Okay, and again, try not to look at this plan up here. Okay, so first thing that you should have listed was angle 1 and 2 are complementary, right? Okay, so I'm just going to go up here and fix this proof from what I had, which was basically the same thing, except it said supplementary. So this is complementary, given. Then what did you say next? Okay, so same thing we did here, but now it's equal to 90. And what did you put for your reason? Okay, definition of complementary now instead of supplementary. Good. So then what did you do next? All right, so then you wrote the next part. Angle 2 and angle 3 are complementary. And that was given. Good. So the reason for number 3 was given. Could I have put both of those in number 1? Yes. And you could have then put both of your next statement that we're going to have next and number 2 in number 2. So it's totally fine if you want to do that. I've just found as proofs have gotten harder that students do better if we separate the givens. Just because I know they're going to get more difficult, I'm going to practice that now. But you can do it either way. So what did you say next? Okay, measure of angle 2 plus measure of angle 3 equals what? 90. And what was the reason? Definition of complementary angles again. What did you do from there? Very good. And which two statements are you combining with transitive? Good. So statements 2 and 4 both had what in common? Yes, but that's not what we use transitive for. 90 degrees. 90 and 90, this whole side was the same. So transitive property would tell us good. Transitive property of equality would give us measure of angle 1 plus measure of angle 2 equals measure angle 2 plus measure angle 3. And then what could we do? Subtract the 2's away. So the reason for number 6 would be subtraction property of equality. And when we subtract the 2's away, what are we left with? Okay, measure of angle 1 equals measure of angle 3. Is that the end of our proof? No, because it said prove they were congruent. So your last step should be angle 1 is congruent to angle 3, and why? Definition of congruence. Is this making more sense? Okay, we're going to get just a little bit harder on the homework. So look at your core math, page 77. We're going to fix